Hello, and welcome to the GridGain University Microlearning Unit, Colocation and Affinity in Apache Ignite. Over the next 8 minutes, you will learn about the importance of colocation in Apache Ignite, how it's responsible for the high performance of Ignite data querying and computation, and you'll learn the basics of how to use it. You might remember from the What is Apache Ignite microlearning unit that the largest latency in any kind of distributed system is network latency. And the next largest latency is caused by disk access. In traditional client-server applications, data is moved over the network constantly, and usually it's accessed from disk. Stored procedures might help to lower the network traffic, but they don't prevent disk access or the bottlenecks caused by all of the queries happening against one physical machine or server. A NoSQL database might help with horizontal scaling, but NoSQL databases don't typically support computations. The data is often denormalized, and joins are usually hugely inefficient. Ignite gives you the best of all of these worlds by allowing distributed in-memory data and computation, as well as a transactional SQL environment, and one that enables you to control the location of your data. The high time cost of disk and network latency means that if we're doing a query that involves multiple tables or performing a calculation on data, it's actually the fetching of that data which is the largest factor in slowing down performance, rather than the actual queries or the calculations themselves. You might remember that Apache Ignite can work entirely in memory, reducing disk access latency. But you'll also remember that it partitions data by default, spreading the partitions across the nodes in your cluster. This has a few uses, but it means that if we're looking for performance and efficiency, we want to be able to predict and control which partitions and nodes our data is on. That way, we can ensure that queries, especially joins, and of course computations, end up in the same place as the data, reducing network traffic to a minimum. There are essentially two types, or stages if you like, of colocation that we need to consider when we're architecting our topology. They are data location and compute location. Data location refers to the practice of keeping associated data together on one physical node, and this is what we consider first. Examples of associated data might be one object aggregating another, or two database tables joined by a key. Now imagine that we have a large banking system with millions of customers stored in a customer table, where every bank withdrawal that each customer makes is stored in a withdrawals table. Now we would want to collocate all of the withdrawals for a particular customer together with the customer record for that customer. That way, if we need to calculate interest or balance totals, a join between the withdrawal table and the customer table will be more efficient. Now, Ignite applies joins on only collocated data by default. And if your data is dispersed over different nodes, you would have gaps in your result sets. You can specify that Ignite allow non-collocated joins, but this would cause increased network traffic as nodes not containing the required data would have to request that data from other nodes in the cluster. This is a consideration in designing and configuring your Ignite cluster. Compute colocation is the second type of colocation that we need to consider. This means keeping our computation execution happening on the same node as the data on which it's executing. So imagine that we want to calculate a percentage bank fee on every bank customer's withdrawal countrywide for the last calendar year. That computation would need to fetch a lot of data, and that could lead to a lot of network latency. So we would want to execute the computation of each withdrawal on the same node that the data resides on. So how do we actually use colocation? Now that we understand the importance and the benefits of it, of course we want to be able to actually apply it in our code. Well, in order to colocate data with other data, or to colocate a compute task with data, we first need a strategy for defining where that data should be and what other data it should colocate itself with. This strategy is implemented in the form of an affinity function. The simplest form of this function is usually just a field or a key from the data object or table. By specifying this key, you ensure that data objects or rows in tables will be distributed to partitions with other data with matching keys. Now, Apache Ignite, prior to version 3.0, uses the term affinity key, whereas Apache Ignite 3.0 onwards uses the term colocate directly, as shown here with the colocate by clause. But the concept is exactly the same. Specifying our customer ID from our customer and withdrawal tables in our example would ensure that all data related to a particular customer would be on one node. At this point, it's worth noting that when we design our cluster topology, we need to consider our colocation functions or keys and make sure that we don't end up with skewed data or data which is poorly distributed over our cluster. If we were to colocate based on date, for example, that would be a bad idea. All of the data from one day would be collocated. But banking transactions tend to happen less on weekends, for example, and we would not end up with well-distributed data. We also want to collocate associated data, and the day of withdrawal is unlikely to be a useful association of all of our bank customers. Now, what about applying our compute task to all of the withdrawals from one customer? Apache Ignite has the syntax to specify a collocated execution. Prior to version 3.0, this was executed via the affinity run or affinity call method, which would specify the key or function used to calculate the location of the data. From version 3.0, the nomenclature has changed to the more straightforward execute collocated. Again, these are the same concept. The key or function used originally to specify the location of the partitioned data is now passed as a parameter to the compute engine, which will run the compute task on that same node. So we can see that the idea of collocating data and compute over an Ignite cluster is fairly straightforward, but it's something that needs to be understood and considered in the design of our Apache Ignite cluster topology. Keeping disk access and network traffic to a minimum is the key to the exceptional performance that Apache Ignite offers.